What this means for my tangent line is that my tangent line at x equals pi over 4 has a slope of 1. I also want to find out the point that this tangent line will pass through, and I do that by plugging in pi over 4 to the original function f. So the original function f was sine of x times sine of x plus cosine of x. I evaluate this, I get root 2 over 2 times root 2 over 2 plus root 2 over 2. Root 2 over 2 plus root 2 over 2 is 2 times root 2 all over 2, which gives me root 2 over 2 times root 2 over 2, which equals 1. So the tangent point is pi over 4 comma 1, meaning my tangent line has a slope of 1 and passes through the point pi fourths 1. I can plug these values into the standard or the slope-intercept form of y equals mx plus b, where I get 1 equals 1 times pi fourths plus b. So b equals 1 minus pi fourths. Thus my tangent line is y equals x plus 1 minus pi fourths, where the 1 minus pi fourths is the y-intercept. Problem 5. I'm given f of x equals x minus 1 times x squared plus 1. Now the original problem wanted us to find the equation of the tangent line to f of x at the point where f of x crosses the x-axis. Okay, this means I want to find the tangent line for f of x at the roots of f of x. So I set f of x equal to 0. This will tell me where f of x crosses the x-axis. This will be where either of my factors equals 0. So I set x minus 1 equal to 0 and x squared plus 1 equal to 0. I either get x equals a positive 1 or x equals plus or minus the square root of negative 1. Problem here is we can't take the square root of a negative number. Meaning the only point where f crosses the x-axis is at x equals 1. That's our tangent point. I can plug in f of 1, but I should already know that this will equal 0. So my tangent point is the point 1 comma 0. I need to now find the slope at this point. To find f prime of x, I need to use the product rule again. Where u equals x minus 1 and v equals x squared plus 1. Take the derivative of both, and I find that f prime of x equals x squared plus 1 plus 2x times x minus 1. X squared plus 1 plus 2x squared minus 2x. I simplify. I get 3x squared minus 2x plus 1. I can plug in the point we're interested in, which is 1, 0, so I plug in the x value of 1. And I find that f prime of 1 equals 2.